Git. Okay. Check. Is everything good? Check. Yep, it is. Oops. Okay. I think we got everything sorted. Okie dokies. Okie dokie. I think we're ready to start. Windows share. Yes. Okie dokie. So, welcome back, peeps. I'm also streaming on Twitch tonight as well for the first time. I've not got a great setup to kind of keep an eye on chat and things, so that'll be coming in the future at some point. So I'm not going to be able to do much with chat, unfortunately, at this time. But if people do join, thanks for coming down. Say hello. Yeah, just like, follow along. Let me know if you're enjoying the stream and if you're getting value from it. And yeah, I hope you kind of like join along for the ride in the future and stuff. So we're in the midst of going through the Git course on Boot.dev, so we are going to jump right back into it. Make sure we're in the proper thing. Yes, we are. Okay, awesome. So I can't remember if I needed to have a terminal for this setup. I can't remember if there was something that we had like last time. Where are we? Let's see. Oops. cd/mount. Oh, mount. D use was it documents, GitHub, and then boot.dev. Yeah, it was either the Webflix or the World Bank one, so we'll see what the tutorial is saying, and then we'll kind of get onto it and stuff. So we're on Git internals. We've got 9 modules to complete tonight. We'll get through all these, and we'll get through all the lessons, of course, as well. So we'll do this. So here we go. So we're on different hashes. My latest Git commit hash was, I'm not going to read all this out. You may have noticed that even though you and I both have the same content in our repositories, we have different commit hashes. While commit hashes are derived from their content changes, there are also some other stuff that affects the end hash. For example, the commit message, the author's name and the email, the date and the time, previous parent/previous commit hashes. All this to say that hashes are almost always unique, and because they're generated automatically for you, you don't need to worry too much about what goes into them right now. No, hash equals SHA. Git uses cryptographic hash function called SHA-1 to generate commit hashes. We won't go into the details of how SHA-1 works in this course, but it's important to know that because you might also hear commit hashes referred to as SHAs. If you're not careful, you'll have two commits with the same hash. False. It's not possible. Woo! First one of the night. Which does not affect the hash of commit. Commits timestamp, commits message, author's preferred text editor, author's name and email. Text editor. Has no bearing. The plumbing. So far we've been using Git in a porcelain manner. But to say our insatiable curiosity, let's take a look at some of the plumbing. It's just files all the way down. All the data in a Git repository is stored directly in the hidden .git directory. That includes all the commits, branches, tags, and other objects we'll learn about later. Git is made up of objects that are stored in the .git/objects directory. A commit is just a type of object. Assignment: use git log-n10 to find your commit hash again. Now I have to remember which one it was in. Use ls-al to list the contents of the I'm pretty sure it was a Webflix one, so like Webflix. See that? Yeah, I think it is because it's got the thing and stuff. So get log gen10. So there was only one commit. Use ls-al. Let's just al. To list the contents of the .git objects directory. Okay, let's just objects. Okay. Look for a directory that suspiciously matches the first two characters of your commit hash. So commit hash up there was like B8, so then B8 is that folder there. Use ls-al to list the contents of the directory in the question. What was it? B8. Interesting. Okay, which of these most closely matches the format of the path of the file? So blah blah blah. Get objects. B8. So there's one with like that with a long hash. That one. The object file. Let's take a look at what's inside the suspicious commit object file. Try to cat the contents of the commit object file, which will interpret the contents as text. So cat and then the file path from before. So cat .git objects B8 and then that. Nope, it's a mess. The contents have just been compressed to raw bytes. Try again with the xxd command to print the contents of the file in hexadecimal format. So same command, and it was xxd. Ooh, interesting. Note you may need to install xxd. Do that again, but redirect the output to a temporary file so the tests can be read. Okay. So this, and then we're going to output it to so temp, whoops, like that, temp commit object, commit underscore object, commit object hacks txt. Run and submit the tests. Okay. There's a copy there. I think that's right. I have to tell you, this CLI tool is absolutely incredible for like this kind of like interactive learning. It is something else. Very, very good. Luckily, Git has built-in plumbing called a cat file that allows us to see the contents of a commit without needing to futz around the object files directly. So git cat file -p and then the hash. Use cat file command to view the contents of your last commit. Okay, so copy that command, but then change the hash. Where was it? That. Oh, hold on. Okay. For the CLI, be able to check your output, do it again, but redirect the output to a temporary file. So let's copy that a bit. Run and submit the thing. Nice. Ta-da! This is very, very cool. Trees and blobs. Now that we understand some of our plumbing equipment, let's get into the pipes. Here are some of the terms to know. Tree, Git's way of storing a directory. Blob, Git's way of storing a file. Here's what I got when I inspected my last commit. Yeah. Notice we can see a tree, object, the author. Still use the AOL address. Nice one, Prime. I'm going to send all spam to that. The author, committer, the commit message. However, we cannot see the contents of the contents.md file itself. That's because the blob object stores it. Use the git cat file p -p again, but this time with the hash of the tree object instead of the commit hash. You should see a blob object in its own hash. So do that. Git cat cat file -p like that. Oh wait. I just copied the wrong one. Git cat file -p. The blob. Use the cat file again to view the contents of the blob object. So we take the blob object, we do cat file -p contents. The same command, but this time redirect the output to temp file like that. So like that. Run the command. So just run the test command just in case. Don't lose my streak. Yay! Second commit. Reminder of the command syntax. Git log, Q to exit, arrow keys to scroll. Git cat file -p hash. Log is a porcelain command, while cat file is a plumbing command. You use log much more often when working on coding projects, but cat file is useful for us in this course to understand Git's internals. Create a second file called tiles.md and add the following text. Okay. If we can do that. Oh no. Okay. What was it to quit? Write out control Control X. Save, stage, commit, and add the file. Save, stage, and commit the file with any commit message as long as it starts with B:. For example, B:, add tiles. I'll just copy that bit for bit. So git git add, git add all, git status, git commit, and then try out, exit. Use git cat file to inspect the commit you just made. You should notice one extra field in the commit object that wasn't present in the first commit. A parent, yeah, okay. Ta-da! Storing data. So Git stores the entire snapshot of files on a per commit level. This was a surprise to me. I always assumed each commit only stored the changes made in that commit. Git stores the entire snapshot of files on a per commit level. This is a surprise. I always assumed each commit only stored changes made in that commit. Huh? Git stores the entire snapshot of files on a per commit level. This is a surprise to me, as I always assumed each commit only stored the changes made in that commit. Not sure what he means by that. Optimization. While it's true that Git stores entire snapshots, it does have some performance optimization so that your .git directory doesn't get unbearably large. Git compresses and packs files to store them more efficiently. Git deduplicates files that are the same across different commits. Files and change commits get only store it once. Assignment. Use git cat file-p to view the hash of the blob of the titles MD file in your last commit. Save that hash somewhere in your notes. Add a new directory in your project called quotes. Right, so get that one first. So titles. Was it the blob thing? So git. Whoops. Git dash cat dash file dash p. That. What was it? The titles.md. I'll hold on to that. Copied. Then create a new directory called quotes, and inside add two file styles.md. So mkdir. Actually, just touch quotes / Star Wars.md. Okay, can't do that. Quotes touch quotes star touch June.md. So quotes Star Wars MD. Okay, so oops, not that. Oh no. Abort. No, MVim. Oh no. Edit anyway. So copy that, and then insert, paste, and exit. Right, quit. Cat, just check that. Yep. Okay. So mvim quotes June, insert, paste. Still getting used to Vim. Stage and commit both files. Stage and commit both files in a single commit with a message sign with C. So adding C:, add quotes. Whoops. So let's check things. So git add all. Whoops. All git commit dash m. Whoops. Let's do it like that. Okay, use the cat file command to view the hash of the blob for titles.md. Again, in the latest commit, you should notice that it's still the same hash because the file hasn't changed. Run and submit the things at the root. Okay. Oh, very nice. Run that. Ta-da! Chapter 4. Git config. So Git stores author information so that when you're making a commit, it can track who made the change. Here's how you might update your Git configuration. Don't do this yet. Blah, 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 blah. So the Primogen and the Primogen at AOL.com. Let's take the command apart. Git config, command to interact with your Git configuration. Add, flag stating you want to add a configuration. Global, flag stating you want this configuration to be stored in your Git config. The opposite is local, which stores the configuration in the current repository only. User, the section, name the key within the section. The Primogen, the value you want to set for the key. Assignment. You can actually store any old data in your Git configuration. Granted, only certain keys are used by Git, but you can store whatever you want. Set the following useless key value pairs in your local Git configuration for the Webflix repository. Omit the global flags to set them. So, okay. So git config add, add. And then you do list it all, local stuff. Yeah. You can also just view the contents of your local file with the cat git config. Like that. It's the same. Very good. So run this test command. Very easy, mac and squeezy. Yippity skippity. Very nice. Okay. We've used list to see all the configuration values, but the get flag is useful for getting a single value. Git config get and then the key. Keys are in the format of section and key name. For example, user.name webflix.ceo. Use the get flag to get the value of the Webflix valuation key from your local Git configuration. Run and submit the things. So we don't really do that. Like, but just to test that we know what we're talking about, so it's going to be git config get that mid. Run the test. Boom. Unset. So unset flag is used to remove a configuration value. For example, unset. So remove the web CTO key from your local Git configuration. Verify it was moved with unset. Try using unset to remove the entire thingy section. So git config dash unset. Like that. So it's gone. And then try and remove the whole section. So if we unset like that, key does not contain section webflix. It failed because you can't unset an entire section, it needs a key. Nice. Duplicates. Typically in a key value store like a Python dictionary, you aren't allowed to have duplicate keys. Strangely enough, Git doesn't care. The unset all. So the unset all flag is used if you ever really want to purge all instances of a key from your configuration. Conversely, the unset flag only works on a single instance of a key. So git config unset all example.key. While only the most unhinged projects operate this way. Some projects include Webflix, allow multiple CEOs that add a few more CEOs to Webflix configuration like this. And then we'll view it. Take a look at your cursed new configuration. Look at all of them. What the hell are they doing in there? The heck they doing in there? Remove all the CEOs from Webflix using the unset all. So do that. It's going to be Webflix with all complete. Oh, very nice. Not complete. And then we'll run this command. They will all be gone, so they will all be taken away. Remove a section. As I pointed out before, the Webflix section is nonsensical because Git doesn't use it for anything. Or we can store any key value pairs we want our Git configuration. That doesn't mean we should. The remove section flag is used to remove the entire section from your Git configuration. For example, like this. Remove the entire Webflix section from your local Git config. You might notice that the default core section is still there. That's okay. Run the thing like this. So Webflix. What's it called? Not called Webflix. The entire section. Webflix. Ta-da! And we'll run that. Whoops. We're going to submit a test from the root of the Webflix directory. I am in the root of the Webflix directory. Oh, happy days. Very nice. So, alright, half an hour in. Blimey, we've got to whizzy through these. There are several locations where Git can be configured, but from more general to more specific, they are system, etc. Git config, a file that configures Git for all users on the system. Global, a file that configures Git for all projects of a user. Local, a file that configures Git for a specific project. And worktree, Git config worktree, a file that configures Git for part of a project. In my experience, 9% of the time you'll be using global to set things like username and email. The other 9% of the time you'll be using local to set project-specific configurations. The last 1% of the time you might need to futz the system and worktree configurations, but it's extremely rare. Overriding. If you set a configuration in a more specific location, it'll override the same configuration in a more general location. For example, if you set user.name in the local configuration, it will override the user.name set in the global configuration. So system, global overrides system, local overrides global, worktree overrides local. Very cool. Suppose you set the username parameter at the system level, user.name lane at the global level, and username.tj at the local level, which will actually use tj. Same thing again, which is stored in the user's home directory. Hold on, it's going to be the global one, right? Yes. Global flat user anyway. Woohoo! Chapter 5. 1, 2, 3, 4, 5, 6, 7. 7 to go. Hopefully these won't take too long. We can get through in one night. So what is a branch? A Git branch allows you to keep track of different pages separately. For example, let's say you have a big web project and you want to experiment with changing the color scheme. Instead of changing the entire project directory as of right now, our master branch, you can create a new branch called color scheme and work on that branch. When you're done, if you like the changes, you can merge the color scheme branch back into the master branch, to keep the changes. If you don't like the changes, you can simply delete the color scheme branch and go back to the master branch. under the hood, a branch is just a name pointer to a specific commit. When you create a branch, you are creating a new pointer to a specific commit. The commit that the branch points to is called the tip of the branch. Branch is just a name pointer to a specific commit. When you create a branch, you're creating a new pointer to a specific commit. The commit that branch points to is called the tip of the branch. Okay, tips of the branch, commits. Because a branch is just a pointer to a commit, they're lightweight and cheap resource-wise to create. When you create 10 branches, you're not creating 10 copies of your project on your hard drive. Check which branch you're currently running by running git branch. It's going to be master. Easy weezy. We've been using Git's default master branch. Interestingly, GitHub, a website where you can remotely store Git projects, recently changed its default branch from master to main. As a general rule, I recommend using main as your default branch if you work primarily with GitHub, as we will. To rename an old branch, git branch -m old name new name. Change your global Git configuration to use main as the default branch. Change init default branch key to main. Okay, so it's going to be git config global init default branch main. So then git config list. I got my headphones in the way so I can't see. Where is it? Yeah, okay, it's set. Cool. Check your current branch, git branch. Git branch. You should notice that you're still a master. That's because all you did was change the default branch for a new repository. Switch to switch this repo to use main. Rename master to main. Git branch again to make sure you're on the main branch. So it's going to be this command, git branch -m, and it's going to be old name, new name. Git branch, git branch, main. I'm going to submit that because we're pretty damn confident it's going to work. Woohoo! Visualizing branches. Throughout the rest of this course, we're using text to represent branches and commits. For example, ABC main means a branch called main with 3 commits. C is the most recent commit, the tip. B is the previous commit, and A is the commit before that. To represent multiple branches, we'll use multiple lines. So ABC on main and D and E on other branch. Assignment. Answer the question based on this diagram. Which commits are part of Lane's branch? So A, B, G, and H. There it is. Yeah, same thing again. So which commits are part of main? A, B, C, D, E. A, B, C, D. A, B, C, D. I'll say E as well. And again, which commits are part of Prime's branch? So A, E, and F. New branch. You should already be on the main branch, your default branch. Whoops. You can always check with git branch. 2 ways to create a branch. Git branch, new branch. This creates a new branch called my new branch. The thing is, I rarely use this command because I usually want to create a branch and switch to it immediately. So I use this command instead. Git switch -c new branch. The switch commands allows you to switch branches, and C flag tells Git to create a new branch if it doesn't already exist. When you create a new branch, it uses the current commit you are on as the branch base. For example, if you're on main branch with 3 commits A, B, C, and you run git switch -c my new branch, your branch will look like this. 2 branches, same commits. So yeah, commit, branch tips, and then you've got a new branch and main. Assignment. Create and switch to a new branch called add classics. It should have the same commits as main. So it's git switch -c. I don't normally use it like that. Git switch -c add classics. Run git branch to verify you're on the new branch. I don't need to do that. I'm already pretty confident I'm already on it. Bastard, flying colors. Almost done with branching. Switching branches. We talked about using git switch to change branches. There's another command that you'll certainly run into because we've been around for a long time and older developers are used to it. Git checkout. Git switch is a newer command that is meant to be more intuitive and user friendly. It's recommended you use git switch or git checkout for simply switching branches. To switch to a new branch, call prime, git switch prime, or the old way, git checkout prime. For this course, we'll stick to git switch. Switch to main, run git branch to make sure it worked. The branch one has asterisk next to it, and switch back to git classics, git branch to make sure it worked. Okay. I'm pretty sure it's going to work, so we'll just run it. Easy. Ooh, I got a sharpshooter test. I'll check all these things at the end. I'm not kind of bothered about the rewards and stuff. They're fun, but not the reason why I get through it. I want to get through it because I want to get through it. And that is that. So we'll see. Okay, we keep going. Up-leveling our abilities. We'll use the add classics branch to add a commit to the project without affecting the main branch. We'll be creating the following branch structure. Main, add classics. The add classics branch will have all the commits from main branch plus a new commit. Switch to the add classics branch if you're not already on it. Well, I was already on it. Create a new file called classics.csv at the root of the project and copy and paste it into the following. So, whoops. So nvim, and what's it going to be? Classics. Classics.csv. Classics.csv, yeah. Oops. Stage should commit as a new file. The message D is the same as the previous exercises. So D: run git log to make sure everything looks as you expect. So git stage should check git add all git commit commit dash there was D: the classics. I even actually look what was in the CSV, wasn't it? Director, One Crazy Summer, Princess Bride. I need to watch that, Princess Bride. The Goonies, Not Really Too Fussed. The Breakfast Club, Monty Python and the Holy Grail. I need to watch that as well. The classics. There we go. Run git log to make sure it's everything expect. Git log. Yep. And then run and submit the CLI. I'm just confident it's going to work. So here we go. Yowza Bowser. There we go. Peasy weasy. So log flags. Log flags, what are these? As you know, git log shows you the history of commits in your repo. There are a few flags I like to use from time to time to make the output easier to read. The first is decorate. It can be one of short, full, and no. Git log dash decorate full. You should see, instead of your git branch name, you should show the full ref, and a ref is just a pointer to the commit. So do this, see what it does. Okay. How's that different to the... Oh, right, I see the full, right. Okay, yeah. Okay. Run git log decorate dash no. You should be able to see the branch names are no longer shown at all. Yeah. The second is one line. This flag will show you a more compact view of the log. I use this one all the time. It just makes it so much easier to see what's going on. So get one line. Oh yeah, that is useful. That is good. I like that. That's nice. Assignment: run git log in the full decoration and the one line flag. Then run and submit the CLI tests. Git files. Kung Fu? No. Gitfu. Remember, Git stores all its information in the in files in the Git subdirectory at the root of your project, even information about branches. The heads or tips of branches are stored in the Git refs heads directory. You can cat one of the The heads of the tips, okay. If you cat one of the files in that directory, you should be able to see the commit hash for the that branch points to. Use find and cat to find the commit hash for your main branch points to. So find main. No, it's file directory. So find. I forgot how to use find dash help. Find -h path and expression, so find and then it's in the git directory. Whoops, git main. Whoa, a little bit too much. Git refs head, so I'm going to do git refs head main. Okay, no such file, that's fine. And then we'll and then cat it, so cat git refs heads main. Okay, what is stored in git refs heads? One file for each commit containing the branch and the commit it belongs to. One file for each branch containing the commit hash of that branch points to. One directory for each commit. What is stored in git refs directory? So slash git refs heads. Oops. Wait. One directory for each branch containing the commit hashes for the branch it points to. No? In the git refs heads directory, where it's stored in git heads. One directory for each branch. One directory for each commit containing the branches that the commit belongs to. Is it that? Well, it's not file. Or is it file? My dum-dum. Whoops. One directory for each commit containing the branches. One file for each branch containing the commit hashes belong to that branch. Whoopsie daisy. Heads, main, and then yeah, okay. Oh, chapter 6, merge. We're doing time-wise, we're doing okay, right? Right, Primigan, let's see what you gotta say. The Primigan. Okay. Merge, what's the point of having multiple branches, you might ask? They're most often used to safely make changes without affecting your or your team's primary branch. However, once you're happy with the changes, you'll want to merge them back into the main branch so they can make their way into the final product. Here we go. Let's see what the Primigan says.
Branching in Git is practically free, and it really is kind of the core operation when using Git. But at some point, you have to get that work from a branch back into the main line. And this is where merging comes into play. Now, a typical workflow for pretty much every dev looks like this. First, we need to update our repository to the latest code. This is typically done through git fetch or git pull. We'll cover those more later. You branch off the main branch and give it a name that kind of represents what you're working on. New feature A. You fix the bug, create the feature, update the docs, and create your one or more commits on that branch. Then finally, you merge those changes back from your branch into the main line. Typically, when you're at a company, this will involve some sort of pull request on GitHub, on Stash, on GitLab, but conceptually, it's no different than executing git merge on the command line.
Okie doke, thanks Primigan. So visual, let's say you're in a state where you have two branches each with their own unique commits, ABC and then D and E. If you merge other branch into main, Git combines both branches by creating a new commit that has both histories as parents. In the diagram below F, is a merge commit that has C and E as parents. F brings all the changes from D and E back into the main. So F brings all the changes from D and E back into the main, yeah. Assignment: switch to the main branch. Next, our contents MD file is eerily empty. Update to contain this. Okay, so switch back to main. Git switch main. And then vim, what was it? Contents. And then insert. Okay. Commit the changes of the message style with E colon. It should look like this. So git add all git. Oops. Hold on. That's fine. Git commit. And it was E colon, was it? E colon eerily empty. And then run git log one line dash graph all. It looks something like this. Ooh, that's kind of pretty. You should see a nice ASCII 2 art representation of your commit history. Run and submit the tests. Ooh. Merge commit. So merge commit is a result of merging two branches together. Right here. Let's see. What's the primer gonna say this time?
We are merging two branches together with diverging history. Look at this thing right here. The diverging history simply means that main branch, the one we branched off of at point A, has commits, and we, some branch, have added more commits. Main has B and C, our branch, some branch, has D and E. That means when we merge, we need to be able to create a new commit that represents these two diverging histories as one. This is called a merge commit, and it's the only commit with two parents. The process for a merge commit looks like this. First, we need to find the merge base. The merge base, also called the best common ancestor, is the nearest ancestor that is in common to both branches, and in this case, that would be A. We then play main branch's commits into a new commit, and then we play some branch into that same commit. When all the changes are in that new commit, we commit it to main, and in this case, we call it F, and we give it two parents, one parent pointing to C from the main branch and the other parent pointing to E from some branch. If you use git log, you will actually be able to see the diverging from A, the two diverging commits, and then the coming back together in F.
Cracking. So let's say we start with this main and vim chads only, A, B, C, and then D and E, and we merge vim chads only into main by running this while on main. Git merge vim chads only. The merge will find the merge base commit or best common ancestor in the two branches, in this case A. Yep, that one. Replays the changes from main, starting from the best common ancestor into a new commit. Replays the changes from vim chads only into main, starting from the best common ancestor. Records the results as a new commit, in our case F. F is special because it has two parents, C and E. Assignment: your current Webflix commit history looks like this. Merge the changes from add classics into the branch using the main branch. You'll represent you'll be presented as a code editor to change the commit message. Update the message start with F colon. Aside from that, use the default message of like that. Okay. So we're going to merge. So git switch main, ready on main. So git merge. What is it? Add classics, and then we're going to paste that. and then it's going to be forget how to save, write out, enter, and quit. Save the file and close the editor. See the tips below if you don't know how to exit the editor. From main, run the this command. Whoops. This should give you a nice visual representation of the merge commit. Yeah. Easy McSqueezy. Merge log. Okay. These back on. I almost have to put them, keep them on permanently if you keep talking to me, Prime. One sec, I just want to check on something. Okay, yeah, just checking something. Here we go.
Logging has to be one of the best tools in the Git belt because Git has extensive logging and observability. If you need to recover work, visually understand how you got to this point, commits along the way, messages that you have created, where the branches and tags are, including in your repository, your remote repository, and of course all the tags that you currently have, and much more, then logging has it. Let's break down a quick command right here. Git log, one line, graph, decorate, parents. Now this looks like a lot of options, but actually it'll make a lot of sense once you understand what those options mean. One line will give you a condensed view of your history. First off, the hashes are shortened to 7 characters, which is the minimum amount Git requires for you to specify a hash. Also, you get the commit message. This gives you a nice quick view so you can see what happened in the past. Graph will draw all the little lines so you can see exactly how your commits have diverged and come back together through merges. Decorate will give you the branch and tag information. This can be nice to see how far you've strayed away from a branch or where a previous branch might be. Parents will give you the parent commit upon every other commit. This can be very nice for merge commits because you can see where the 2 parents came from to create the merge commit. Go ahead, give it a try yourself.
And I will, and I'll keep my headphones on now. The output should look similar apart from the hashes, should look the same. Give it a try. Yeah, it looks pretty. Each asterisk represents a commit in the repository. There are multiple commit hashes on each line because the -- parents flag logs the parent hashes as well. The first line of these 3 hashes, these is our recent merge commit. The first hash is the merge commits hash. The other 2 are the parent commits. The next section is a visual representation of the branch structure. It shows the commits on the add classics, the branch in the main branch before the merge. Notice that they don't share a common parent. The next 3 lines are just normal commits, each pointing to their parent. The last line is initial commit and therefore has no parent. Why does the first line show 3 commit hashes? Because it's the first commit in the repository, because this is a merge commit. And it, whoops, I didn't read both. It shows its own hash and the hash of both its parents. Another vid. Merge log. Oh wait, hold on, we're already doing this one. Why the weird diagram, pipe / pipe star pipe and blah blah blah. It's what happens to your brain on actual Linux after 10 years. It's a graph showing 3 commits were merged into main. It's a graph showing add classes was merged into main. It's a bug in the code. 3 commits were merged. That. Yes. Fast forward merge. The simplest type of merge is fast forward merge. Let's say we start with this. Delete VS Code and main. Yeah, I will at some point. And we run this while in main. git merge delete VS Code. Because delete VS Code has all the commits that main has, Git automatically does a fast forward merge. It just moves the pointer of the base branch to the tip of the feature branch. Notice that the fast forward merge has no merge commit is created. This is a common workflow when on Git with Git on a team of developers. Create a new branch for a new change, make the change, merge the branch back into main or whatever branch your team dubs the default branch, remove the branch, repeat. Assignment, because add classics branch has been merged into main, we don't need it anymore. Delete the add classics branch, so we'll do that. Create a new branch off of main called update titles. You can use the git switch one. Git switch C, update titles. Add a commit to the branch that updates the titles MD file. Add the curious case of Benjamin Button. As the final entry, use the G colon for it, okay? So, what was it? Titles. And then give it file entry to pre-commit message. So git add and it's going to be that all Benji. And git log one line, git log on line. Whoops. Oh, one line with no dash. Okay. Run and submit the updated titles thing. Last one on this page. So fast forward commit. Here's a giant fast forward commit before merge. Before and then after. No merge commits created. Switch back to the main branch. So git switch main. And then make sure it doesn't have that last G commit with a quick git log. It doesn't. Nope. And then merge your updated titles branch into main. You should see fast forward merge happen automatically because main doesn't have any commits that are already in update titles. Delete the update titles thing. So what was it called? Update merge update ones. Yeah, merge. Fast forward. Yeah, and then delete the branch like that. Git branch. Tiles. Delete. And remember the CLI. Easy peasy. Okay, I think we did that, didn't we? Ooh, rebase, right? This is something I never really use in Git, which is rebase, and so it should be interesting to cover. So, rebase versus merge is one of those hotly debated topics in the Git world. A lot of the discussions you'll see online come down to the fact that many developers, yes, even professionals, don't understand the purpose of rebase and use it incorrectly because a bunch of Git causes a bunch of Git havoc and then blame the rebase command. It's not Git's fault, it's a skill issue.
Rebase might just be one of the most misunderstood features of Git. Where the fear typically kind of comes from is that somebody changes the history of a public branch. And when I say public branch, I mean a lot of people rely on this branch for their repos as well. And of course, when they pull and the changes have been somehow altered in the past, all these conflicts and these weird Git errors start happening, and it just causes a disaster for everybody. And then everyone says, rebase is terrible. I will never use that, only use merge. Well, skill issues. You used it wrong. To understand rebase, you simply need to understand its primary use case. Rebase helps you to take the diverging commits from one branch and move them to the tip of the base branch that the feature branch is based on. Now that sounds like a mouthful, but it's actually pretty simple. So take this graph right here. We have two branches, main and feature. Feature branches from main at commit A, and main gets B and C added to it, while the feature branch has D and E. Now we want to be able to take the feature branch and get those changes from main. Now with your current knowledge, you would probably merge main into feature, creating a merge commit, and that does have consequences, and we'll discuss more about that in part 2. But for now, let's focus on rebase. Rebase is going to allow you to move forward feature branch from diverging at point A up to diverging off of point C, allowing for a fast forward merge if you wish to get it back into main. This also allows you to maintain a merge commit free history, and again, there are some consequences for that, and they can be quite nice. And that is it. You'll notice this gives you the opportunity to do a fast forward merge and kind of have a free of merge commit history. This will allow for some advanced Git features to be more easily usable if you maintain this type of workflow.
Yeah. Okay, let's see. So it's just explaining basically what you already mentioned there. So say we have this commit history. We're working on feature branch. We want to bring in the changes our team added to main, so we're not working with a stale branch. We could merge main into feature branch, but that would create an additional merge commit. Rebase avoids a merge commit by replaying the commits from feature branch on top of main. After a rebase, the history will look like this. Both rebase and merge can be used to integrate changes from one branch into another. Yes. That's just the same thing. Boop can add an additional commit. Boop does not. Merge and rebase does not. New branch. Oh, how many things in this one? 6. New branch. We need to create a new feature branch, but to be able to practice a rebase, we want it to not include some of the recent commits of main. Use git switch command to create a new switch to a new branch called update Dune. But branch off the D commit. You can supply the commit hash directly to the git switch command. So command. So git log. Okay, so what is that? So copy that, and then the git hash is going to be this. You can supply the commit hash directly with the git switch command. I did that. So whoops. Replace git commit hash with blah 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 blah, and then log, verify the log with n1. You're now on the branch. D is the last commit. Verified. Let's see what that does. Run rebase. To use rebase to bring changes from main into current branch, let's pretend we're on one called JDSL. We would like to we would run this while on the JDSL branch. Git rebase main. This will do the following. Check out the rebase run changes from main into a current branch. Okay. This will do the following. Check out the latest commit from main into a temporary location. Replay each commit from JDSL one at a time onto this temporary location. Update the JDSL branch to point to the last replayed commit in the temporary directory, making this new permanent JDSL. The rebase does not affect the main branch. JDSL now includes all the changes from main. Add 2 commits to the update Dune branch. Add the following quotes to Dune.md. List of files. Use commit. All right, okay, 2 different commits. So mvim quotes Dune. Okay, so down. And git commit. It was h colon spice baby. Whoops, forgot to add. And then fear is the mind killer. And what was it? I colon fear. Okay. While still on the update Dune branch, rebase your changes onto main. Main is the base and we want to update Dune's change on top of it. Okay, while still on update Dune, we want to rebase your changes onto main. Okay, so then git log one line. Even though we originally branched off a D, from main we should see a nice linear history from A to I. A, B, C, D, E, F, G, H, I. Yeah. Run and submit the CLI chances. So this is what happens. So update Dune. I main. Okay. Okay, when to rebase. Git rebase and git merge are different tools. The advantage of merge is that it preserves the true history of the project, shows when branches were merged and where. One disadvantage is that it can create a lot of merge commits, which can make the history harder to read and understand. A linear history is generally easy to read, understand, and work with. Some teams enforce the usage of one or the other on their main branch, but generally speaking, you'll be able to do whatever you want with your own branches. Warning, you should never rebase a public branch like main onto anything else. Other developers have it checked out, and if you change its history you'll cause a lot of problems for them. However, with your own branch you can rebase onto other branches, including a public like main, as much as you want. It's generally good manners to rebase a public branch onto your own personal branch. False. When to rebase. It's generally okay to merge changes into your own private branch or rebase your branch onto a public branch. Undoing changes. One of the major benefits of Git is the ability to undo changes. There are a lot of different ways to do this, but first we'll start with going back. Reset. We're on reset now. We're 8 out of 11. Cool. Ooh, danger, danger. One of the major benefits of using Git. Let's just put that. One of the major benefits of using Git is the ability to undo changes in a lot of ways, but this is first we'll start going back to the commit history without discarding changes. Assignment. The new internet Webflix tried to add his favourite movie to the titles MD, but he overwrote the entire file by mistake. To simulate that on the update Dune branch, go ahead and overwrite titles MD with this line. Okay, so we're on Git branch. We're on the update Dune one, so do that. And then make sure the file is changed by running git status and then the commit change with a J colon. So git add all commit And then it's going to be, what was it? J colon, whoops. Crazy. Okay, these are things that I've gotten confused with in the past as well. So we'll see what these mean. Right, so let me just check on something. Anybody on? It is quiet tonight. One person viewed on Twitch, but otherwise not many around. Let's start spreading the word. The git reset command can be used to undo the last commit or any changes in the index stage but not committed changes, and the work tree unstaged and not committed changes. So the git reset command can be used to undo the last commit or any changes in the index staged but not committed changes, and the work tree unstaged but not committed changes. Git reset -- soft commit hash. The soft option is useful if you want to go back to a previous commit but keep all your changes. Commit changes can be uncommitted and staged, while uncommitted changes will remain staged or unstaged as before. Assignment: your current branch update Dune should be at commit J with a change file titles.md. Get the I commit hash from git log and then git reset the hash and go back to I, while keeping the changes in title.md. Staged but not committed. J should be gone from the commit log. Okay, whoops. What is it? Git log. Let's display that. For which one? I. So git reset -- soft git log bingo wingo. Reset hard. In the last lesson, we undid the commit but kept the changes. We don't want to keep the changes to titles.md. Here's how to reset those changes. So git reset -- hard commit hash. This is useful if you want to go back to a previous commit and discard all the changes. Run git status to confirm the stage change that modified titles.md. So git status. Yep, staged. So git reset -- hard. I commit to undo the changes. So we run that. Git reset -- hard. Check to make sure the files is reset. Git status. Git status. Gone. And then we run this command. Danger. I want to stress how dangerous this command can be. If you were simply to delete a committed file, it would be trivially easy to recover because it is attracting Git. However, if you use git reset -- hard to undo committing that file, it will be deleted for good. Always be careful when using git reset -- hard. It's a powerful tool, but it's also a dangerous one. Reset to a specific commit. If you want to reset back to a specific commit, you can use git reset -- hard command and provide a commit hash. For example, that this will reset your working directory and index to the state of the commit, and all the changes made after that commit are lost forever. Again, be super careful with this. In part 2 of this course, we'll cover more advanced, read safer ways to undo changes. So git reset -- hard undoes commit changes but keeps the stage stash for safekeeping, undoes all changes, deleting changes forever. When provided a hash, git reset -- hard, moves your current branch back to the older commit and destructively discards uncommitted changes. Adds a new commit, effectively undoes the changes in the provided commit, that one. So it moves your current branch back to the older commit, destructively discards uncommitted changes. Woo, we're on remote, so we're almost done. And it's only 20 to 10, so we might get this finished, and then we might have to have a little sneak peek at what's going on in the next course. I'll have a little sneak peek. We get through it. Git remote. Often our frenemies, read co-workers, make code changes that we need to begrudgingly accept into our pristine bug-free repos. /s. Not sure what that means. This is where the distributed version control system comes from. We can have remotes which are just external repos with mostly the same Git history as our local repo. When it comes to Git, the CLI tool, there really isn't a central repo. GitHub is just someone else's repo. Only by convention and convenience have we as developers started using GitHub as a source of truth for our code. Create a second repo called Webflix local as a sibling directory to our original Webflix repo. CD blah 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 and create a new repo. And when you're done, your directory structure looks something like this. Submit the CLI test runs from Webflix local directory. Okay. So CD, okay, there, this, CD, that. Ooh. Get in it. Nice and easy. So adding a remote. In Git, another repo is called remote. The standard convention is that when you're treating the remote as a authoritative source of truth, such as GitHub, you name it the origin. By authoritative source of truth, we mean that it's the one you and your team treat as the true repo. It's that one that contains the most up-to-date version of the accepted code. So git remote add name and then URI. Assignment: inside a new repo, Webflix, add Webflix as a remote. Give it the name origin. The URI should just be a relative path to Webflix directory. In our case, /webflix. Run some so git remote add name. It's going to be origin and then Webflix, like that, and then run this command and see what it is. Whoops. I name it wrong. Whoops, I spelled it wrong. Screwed up my run straight because of a typo. Fetch. Adding a remote to our Git repo does not mean that we automatically have all the contents of the remote. First, we need to fetch the contents, but not yet. Git fetch. This downloads copies of all the contents in the Git objects directory and other bookkeeping information from the remote repository into your current one. Before fetching the data itself, let's take a look at the new empty repos Git objects with find. So find. Oh, it's a little bit empty. It should be really empty. Only 3 directories because we haven't fetched anything yet. Still without fetching, submit the commands. Making fetch happen. Now to bring the remote Webflix repos into our local fetch, you have to fetch it. Run git fetch and then git find. So find thing again. So git fetch. And whoops, no, not that. Easy peasy. Not fetch. Just because we fetched all the metadata from the remote Webflix repo doesn't mean we have all the files. To demonstrate this, run git log, and you should see what you don't have any commits yet. So git log. Main doesn't have any commits yet. Copy and paste one of the following commands into your terminal. So selecting code 128. Log remote. Git log command isn't only useful for your local repo, you can also log the commits of a remote repo as well. Git log remote branch. For example, if you wanted to see the commits of the branch named Primogen for a remote named Origin, you would run this. Assignment: git log on the remote Webflix repos, update Doom branch and use the one line flag. Do it from within the Webflix local repo. You can see the commits A through I. Okay, so git log. Oops. Log remote. Remote. Oh my goodness. Type into that. Get remote and then update. Whoopsie daisy. Oh, remote. Origin. Oh no. Very nice. Last one on this one. And 2 chapters left. Just as we merge branches within a single local repo, we can also merge branches between local and remote repos. Git merge remote branch. For example, you want to merge the Primogen branch off the remote origin into your local main branch. You run this inside the local repo while checked on the main branch, like that. Assignment: merge the remote origin main into the local repo's main branch. Because we're on an empty branch, we should get a nice clean fast forward. Make sure it worked with git log. You should see the commits in your main. Blah blah blah. Blah. So git merge origin main. Ta-da! Aha. Hold on. I don't know if my GitHub thing is connected, so let me just do that. Is it connected? I don't think it is. Let me fix that. Oops. Oh, it is connected by the looks of it. Okay. Okay, I think it's set up. Let me switch back. GitHub repository. GitHub is the most popular website for Git repositories projects online. That is for hosting remotes on a central website. GitHub serves several purposes. As a backup for all your code on the cloud in case something happens to your computer. It's a central place to share your code and collaborate on it with others. As a public portfolio for your coding projects. Git is not equal GitHub. It's important to understand that Git and GitHub are not the same. Git is an open source command line tool for managing code files. GitHub and its primary competitors, GitLab and Bitbucket, are commercial web projects that use Git. The websites give us a way to store our code that's managed by Git. Create a GitHub account. If you don't have a GitHub account, create there. Once you create one, blah, 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 blah. So I'll run the checks. Yay, we're already authenticated to GitHub. I thought so, but we're just checking. Just like we created Webflix local repo and use Webflix as a remote, GitHub makes it easy to create remote repos that are hosted on their servers. Create a new repository on GitHub called Webflix, leave it completely blank and make sure it's public. For now, you have to change it anyways later. Okay. New repository. Create a new repository. Public. Authenticate your local Git configuration with your GitHub account. I recommend using installing GitHub CLI. One quick way is to use install as Webby. Okay. Where? Webflix. So CD, and then we're going to do Git. What is it? Git remote add. Origin. Git config list. Okay, so that make sure to replace your blah 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 blah. Run git ls remote to make sure the remote is correctly added. I won't bother with that for now. Let me make sure you authenticate through your browser, navigate to Webflix as a remote. Origin, ls remote, and then we'll do that. Okay, maybe, okay, right, okay. So we want to install that. That's fine. And then get auth login. Okay. Where do you want to, where do you use GitHub? GitHub. HSH. This one. Log in with a browser. That's all. Let's turn you guys away for a second. Okay, let me check that's all done. Okay. Alright, I think we're sorted. Let me change it back. And then we'll try to run that again. Hope she should work this time. Boom. So git push. Git push commands pushes, sends local changes to any remote in our case. GitHub, for example, to push our local main branches commits to remote origin mains, we could run git push origin main. You need to be authenticated with the remote to push changes, which you should have done in the last session. Alternative options, you can also push local branch to a different remote with a different name. So git push origin, local branch, and the remote branch. It's less common to do this, but nice to know. You can also delete a remote branch by pushing an empty branch to it. So git push origin : remote branch. Let's push your local main branch to the remote origin repo for safekeeping. In your local wet fix repo, switch to main. Okay, git branch main. It already exists. Git switch main. Okay, switch to main. Run git push origin main. Git push origin main. Navigate to GitHub repo in the browser. Make sure all the files and the things that you committed. Run all the checks. Paste your public repo into here like this, and then run all the checks. Pull. Fetching is nice, but most of the time we want the actual files from a remote repo, not just the metadata. So git pull remote /branch. The brackets ... syntax means that the bracketed remote and branch are optional. If you execute git pull with anything specified without anything specified, it will pull your current branch from the remote repo. Let's use GitHub UI to commit GitHub UI. To commit a change to our remote repo, then we'll pull the change down to our local repo. Navigate to your repo in the browser. Show GitHub repo's main base is commit G or Benji. Navigate to the classic CSV file in the main branch. In the top right corner, click edit this file, add a new line to the end of the file. So, where is it? Edit this file. Oh, Benji. Commit and change the UI, but change the commit message to J, updated like this. So commit changes like that. And commit command line, you make sure you use break branch. Commit changes. On your command line, make sure you're on the main branch. Run git pull, rebase, git config, rebase false to make sure git will do a merge on pull. And then git pull. Main, git branch, from main. Measure changes from update doom branch back into main, so it has everything we've done so far. Okay, so git merge main. Run git pull origin main, git pull origin main. Okay. You should see that merge commit starts. Rename the merge commit to start with a K colon. So K colon, and then write out, save, and then exit. Make sure everything works with git log one line, git log one line, Git log for the one line. Here we go. Make sure it was online, and then delete the update to branch locally. So git branch, branch delete update do. Run CLI blah 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 blah. So run the tests. Yippee! Pull requests. So on GitHub, a pull request is a way to propose changes, typically to the rest of your team or to the maintainer of the project you're contributing to. Pull requests allow team members to see what changes are being processed and to discuss them before they are merged into the main codebase. Switch to a new branch called classics off of main. So git switch create like this. Add another line to classic CSV like this. So nvim. Oh wait, no, not the UI. What was it? Classics. Stage of commit and change the prefix to be L. So git add all commit -m. It's going to be L colon. Whoops. L colon psycho. And then push a new branch to GitHub, push a remote, add classics branch. So git push. Yep. Navigate to GitHub, repo in your browser. On the pull requests tab in the top, click new pull request, set the branch name to main, and compare the branch to add classics as we plan to merge add classics to main later. Create a pull request, but don't merge it yet. Okay, create pull request, add classics. Okay, and then put it into your repo, so run that. Yay! Okay. So my workflow, 2 stages on my workflow. While on the topic of pull requests, I want to share a note on my simple workflow. 90% of the time, you're only using a handful of Git commands to get your coding work done. Keep stuff on GitHub. I keep all my serious projects on GitHub. That way, if my computer explodes, I have a backup. And if I'm ever on another computer, I can just clone the repo and get back to work. Rebase versus merge. I configure Git to rebase by default on pull rather than merge, so I keep a linear history. If you want to do the same, you can add this to your global Git config. Git config, global, my solo workflow. When I'm working by myself, I usually stick to single branch main. I mostly use Git on solo projects to keep backup remotely and to keep history of my changes. I only rarely use separate branches. Make changes to files, git add dot or git add files if I only want to add specific files. Git commit -m, a message describing the changes, git push origin main. It's really that simple. Most solo work. Git log, git reset, and some others are, of course, but use them from time to time, but most of the time, core what I do today. My team workflow. When you're working with a team, Git gets a bit more involved, and we'll cover more of this in part 2 of this course. Here's what I do. Update my local main branch with git pull origin main. Check out a new branch for the changes I want to make with git switch create and the branch name. Make the changes to files, git add, git commit, git push origin branch name. I push a new branch name, not main. Open a pull request on GitHub to merge my change into main. Ask a team member to review my pull request. Once approved, click the merge button on the GitHub to merge my changes to main. Delete my feature branch and repeat the branch all over again. Working solo, do I use many different branches or pull requests in my workflow? Nope. Yay! When working with a team, which is my workflow, yeehaw! Force push straight to remote main. Mom ain't raised no coward. Work on a feature branch, then open a new pull request for review. Rebase the main branch, forcing all the teammates to deal with the revised history. Commit and push directly to main, then blame any problems on the new intern. Work on feature branch, then open a pull request for review. Oh, of course. Merge pull requests. In a typical team workflow, you may ask a teammate to review a pull request. If they approve the changes, they would approve the pull request and you'd be cleared to merge. We're the dictators of our own repos, however, so we don't need to wait for approval. Merge the pull request on GitHub to bring the remote add classics back into the main branch. You should see 4 added commits. Merge. Switch back to your main branch locally. Run git pull origin main to bring the change for remote main into your main local branch. And you see fast forward. Delete the add classics git branch -d. Git switch main git pull, and then git branch. Get rid of that, and then we'll run this. Easy McSqueezy. Okay, so git ignore, nested git ignore patterns and stuff. Right? Oh no! Oh no, it's the meme! Heaviest objects in the universe. Node modules. Easily done by a lot of people. As you've seen, it's pretty normal to use the following workflow from top level of your repo: git add, commit, push. A problem arises that when you want to put file in your projects directory but you don't want to track them in Git, a git ignore file solves this. For example, if you work in Python, you probably want to ignore automatically generate files like .pyc and pycache folder. If you are building a server, you probably want to ignore env files that might hold private keys. If you work with JavaScript, you might want to ignore node modules directory. Here's the example: git ignore file which exists at the root of a repo. No modules. So this will ignore every path containing node modules as a section, directory name or file name. It ignores node modules code, source node modules code.js. It does not ignore source node modules 2, env node modules 3. Create a secure password.txt and create a .txt file, and create the secure directory if it doesn't exist. Paste the following into the file and save it. So mvim, and then with that, insert paste. Oops, I always forget that. Quit. Whoops. Right click. Right click. And it's hold on. Nvim no such file directory. No. Can't open file for writing. Can't open file for writing. W sudo t blah 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 blah. If you want to do something. Oh no, I'm trapped. I'm not thinking the meme. Oh no. Vim can't open file for writing. Whoops. Okay, MK there, secure, and then. All right, you win. Oops. Oh my good pleasures. And then blah 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 fails. Guilty pleasures. Guilty underscore pleasures. Guilty pleasures.md. And so, and then whoops. Create a git ignore file at the root. And show both those are ignored, the entire secure directory, not just the password directory. Okay, so nvim .git ignore. Whoops. And then we're going to ignore secure. And then okay. Committed changes you think got in our file. Well, let's start with -m. So git cs, git add all, whoops, all, git commit sm, and then it's going to be m ignored bingo. Where are we to? Doing good. We're gonna finish tonight, definitely, and then we'll have a little peeky at the next thing coming down the pipeline. Anybody on? Nobody at the minute. Your git ignore file does not necessarily need to be at the root of your project. It's fairly common to have multiple git ignore files in different directories throughout a project. A nested git ignore file only applies to the directory it's in its subdirectories. Let's say you have the following set up like this. Here's the contents of source assets of git ignore. Only devs.png and main.py. Here's the contents of the git ignore directory, which is ignored. Maybe got that one. Nested git ignore. Your git ignore file does not necessarily need to be at the root of your project. It's fairly common to have multiple git ignore files in different directories throughout a project. A nested git ignore file only applies to the directory it's in. Alright, which is not ignored. Test.py. Patterns. It would be rough if git ignore files only accepted exact file path section names. Luckily, they don't. Let's go over some of the most common patterns. So wildcards. The character matches any number of characters except for the slash. For example, to ignore all .text files, you just do this. Asterisk.text. Rooted patterns. Patterns starting with a slash are anchored to the directory containing the git ignore file. For example, this would ignore main.py in the root directory, but not any subdirectories. Negation. You can negate a pattern by prefixing it with an exclamation mark. For example, to ignore all .txt files except for important .txt, you could use the following pattern. All.txt, but not important.txt. Comments? 1 second. Comments. You can add comments to your git ignore file by starting a line with the hash. For example, hash ignore all .txt files. Order matters. The order of patterns in a git ignore determines their effect, and patterns can override each other. For example, ignore everything in the temp directory except the instructions. Everything in the temp directory would be ignored except for the instructions MD. If the order were reversed, instructions MD would be ignored. You can read about patterns in the available documentation. Assignment. Use this git ignore file to answer the following question. Source content is not ignored or is ignored? Content. So that's just a comment. All text files, but not this one, is ignored. It's just on its own. Next one, source.mainpy is ignored. Oh, and the last one tonight, boys. Last one, and we'll do some like digging around and having a look at other things and stuff. This is the final required lesson of this course. Let us see what to ignore. We talked about how to ignore files, but deeper question is, what should you ignore? There are some rules of thumb for coding projects. Ignore things that can be generated, e.g. compiled code, minified files. Ignore dependencies, node modules, VMs and packages. Ignore things that are personal or specific to how you'd like to work, editor settings. Ignore things that are sensitive or dangerous, .env files, passwords, API keys, etc. Part Deux. We've covered a lot of Git basics so far. There's certainly more you can learn, but now you have a solid foundation to work with as a developer. If you want more, there's a part 2. There's a part 2 of Learn Git where we cover more advanced topics. Let's ignore a generated file. We ignore generated files because they can easily be regenerated from the stuff that we do track. In this case, we're going to use pandoc to generate HTML from a markdown file. We ignore the HTML file but commit the markdown file. Install pandoc, a command line tool converting between different document formats. If you're on Mac, that. If you're on your Ubuntu, I'll do this. I'll do that. Do that one. Okay, I'll do that. I do that one. Let's see how it go. Whoops. Yeah, that's fine. Okay. Run pandoc-version to make sure the version is installed. Create a new file in the root repository called advert.md with the following content. Okay, and then what was it called? Advert.md. Okay. Run the following command to generate HTML document page or web markdown. So pandoc, advert.mv, blah, blah, blah. Yeah. For fun, open the HTML in your browser, see a nicely formatted markdown version. Linux, so see if that, I'm not even sure if that works, but we'll try that. We can't do that, so what we'll do is we'll just thingy to it. So file, :// whoops, is it? Hold on. Hold on. Cloud. Hold on, let me open the File Explorer. I forgot how to. So GitHub. That one. Boot.dev. Reflex. And this one. Don't need that. This, and then and then add the authorization more. Okay, same thing. Git ignore And then we're going to add advert HTML. It's status. Okay, so get add all commit -m. It's going to be n colon. So n colon adverts. Okay, and then we're going to run this. Beautiful, wonderful stuff. You completed the Learn Git course. Yay! What's this one? Yay! 5 stars. Nothing but the best. Just going to open some of these chests. Woo! Boosh, I love this spaghetti effect. Spaghetti? There it is. There we go. Let's, I'll download it so I can put it into photos. Let's keep track of these. Just nice. Import photo. Downloads. Get in there. Share it on LinkedIn. Go to Boom, I've done those. Okay. Boom, boom, boom. I think that is everything complete for the day. It is 10 o'clock. We are under time, which is good. There's a few little tidbits I could do tonight. And if we go back to the board, sprees, things and stuff. Let's have a look at these, I guess. Continue. Got streak last, yeah, whoops. Milestone diamond. Day structure, new announcement. Data structures, algorithms are now combined. Data structure and algorithms are now combined. To learn data, one course. Okay. That's fine, we'll get to that at some point. My call's red. Boom, here comes the boom, baby. Right, we have finished. We are 3 modules down. 3 out of 23. Okay, and then, well, we've got some more of these stuff, so we're doing good. Doing good. We keep up this pace and stuff, and we'll be doing all right. I'm gonna have a little give you a little sneak peeky of the tomorrow night's one, so just a little sneak peek. So, build a book bot. You'll build a real command line application in Python that does static analysis on text files, or rather entire novels like Frankenstein. You'll be guided through the setup of a professional development environment using VS Code, Git, and GitHub. This is the perfect first Python project for beginners. So, let's have a look at that. Not too much. Lane Wagner, backend developer and lead instructor at Boot.dev. He has taught over 1 million students worldwide at Boot.dev. This is by far probably one of the best platforms I've ever thinking of instance. 6 hours, so should be able to slam this out in like 2 sessions. Maybe we don't go a bit faster, but I'm not going to start the course yet. I'm not going to start the course yet. That's going to be for tomorrow. Tomorrow we do it then. Okay. So let's have a look what's going on. Few people visited on Git on thingy stuff. I don't think my chat studio panel thing is working on OBS very well still, because it was like just not saying anybody was around. Couple of people visited on Twitch, but not many. But it don't matter. We're here and stuff, so enjoyed it. Well, that'll do it for tonight. We got through another one. Tomorrow's going to be a fun project. Yeah, we'll build it up and see what it's got for us. Building now. Building. Have a good night. Thanks for coming back from the future if you have done so. Appreciate you all. It's been fun watching. I'll see you next